Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. So today we're going to be doing Unit 4, Lesson 9. Please make sure that you put your first and last name, period, and the date in the upper right-hand corner. Today's topic is transformations using or with function notation. So hopefully this lesson kind of rings a bell. We did study transformations in, I think, Unit 2. Last semester. So hopefully a lot of this is familiar and it won't feel too new or too scary. And then this is the last lesson of this unit. Next week, we're going to be doing our unit review and our unit test. So good job working hard and getting through Unit 4 with me. So our objective today is I will identify and describe transformations of functions and graphs of functions using function notation. So this first part of our table here, transformations of parent functions. This is just our little cheat sheet. This thing is going to help us describe and recognize the different transformations that occur with our functions. So for horizontal shifts or moving left and right on the x-axis, f of x plus h. So anytime you add a number directly to x, you are going to shift left h unit. So we're going to shift left h units, or move left h units. If you subtract h directly from your x values, so f of x minus h, then you're going to shift right h units. Then for our vertical shifts, if you take the entire function f of x and you add a number k to the entire function, that's going to shift your function up k units. If you subtract k from the entire function, so you take f of x, the entire function f of x, and you subtract a value from it, it's going to shift your graph down, or your entire function down that many units. Right. Then we can also have what we call a vertical stretch or compression. Last semester I talked about it on the horizontal axis. This semester we're going to focus on the vertical axis because that's how MathXL does it. So if you take a number a and you multiply your entire function by that number. So a meaning the absolute, I should say absolute value of a, actually. We want a to be a positive number for this part. So the absolute value of a, if the absolute value of a is greater than 1, so it's a positive number and it's bigger than 1, then you're going to have a vertical stretch by a factor of a. So if you're taking a number that's greater than 1, like 1.5 or 2 or 3 or 4, 10, 100, and you're multiplying that by the entire function, you are going to get a vertical stretch. It's going to make your y values like skyrocket, essentially, grow very quickly. If a is between 1 and 0, so if a is like 1/2, a third, 5/6, 2/4, which is 1/2. I can't think of numbers smaller than 1 right now, but also greater than 0. So it's still positive. We're still taking the absolute value of a when we are figuring this part out. So it could be like 0.7 or 0.6 or 0.4, 0.002. If the number is less than 1, but also greater than 0, so between 1 and 0, then you're going to have a vertical shrink. So what that's going to do is that vertical shrink is going to push your y values down. And we'll see how that works as we do some examples later on. Or, sorry, I didn't mean to use the word shrink. I should have said compression. Same thing. Okay, and then reflection. F of negative x. So if you take a negative and multiply your x value directly by that negative, it's going to flip or reflect your entire function over the y-axis. You're going to have a reflection over the y-axis. But if you take the negative and you multiply it by the entire function, so the difference here is the x was being multiplied by the negative, but here the f of x, the entire function is being multiplied by the negative, it's going to flip or reflect your graph over the x-axis. So this little cheat sheet is going to help us recognize if our transformations are shifting us left, right, up, down, if we're going to have a vertical stretch or compression, if we're going to reflect over the x or the y-axis. So in example 1, we're going to identify all of the transformations that will occur. We're actually going to rewrite the equation of the function, and I don't know why I said and. That's all we're going to do. We're going to rewrite the function with the transformations that occur, and we're going to describe the transformations. Oh my goodness, I just threw my Apple Pencil. Okay, so if our function is f of x equals x squared, in part A here, f of x equals x squared. So the transformations that are going to occur are, we're going to take 2 times f of x plus 3. So notice we're adding 3 directly to x. We're taking f of x plus 3. And then we're multiplying the entire function by 2. So 2 times f of x plus 3 is equal to, so our f of x was equal to x squared. So if I'm going to take 2 times f of x, that's going to look like 2 times x squared. So 2 times my function, x squared. But I also need to add 3 directly to the x. So I'm going to have x plus 3 squared. So our new function is written as 2 times x plus 3 squared. So what transformations are taking place? There are 2 transformations. I have the 2 times the function, and I have the added 3 directly to x. So what does adding 3 do? Adding 3 directly to x, f of x plus h, shifts our graph h units to the left. So we're going to, our first transformation is it shifts left h units. Just kidding, h is 3, so shifts left 3 units. All right. Then what does the 2 times the entire function do? Well, the absolute value of 2 is 2. And 2, now we need to decide, is 2 greater than 1 or is 2 between 0 and 1? Well, 2 is greater than 1, right? So if 2 is greater than 1, that means we have a vertical stretch by a factor of 2. So we have a vertical stretch by a factor of 2. All right, why don't you try this next one on your own? So your parent function is f of x equals x squared. The transformed function is going to look like negative f of x minus 4. So notice the minus 4 is outside the parentheses. You're subtracting 4 from the entire function, not just x. And you're multiplying f of x by a negative. So here's how we're going to set this up. F of x is equal to x squared. So you're taking the negative of f of x minus 4 equals, go ahead and give that a shot. What is that equation going to become? And then tell me what the transformations are going to occur. So what does that negative outside of f of x do? What does subtracting 4 from the entire function do? Press pause and then press play when you're ready to check your work. All right, so you should have described 2 transformations. The first being that we shift down 4 units. The second is that it's reflected over the x-axis. So the way you should have written your equation, your new function, is negative x squared minus 4. So as you can see, I just took the negative of f of x, which was x squared, and then I subtracted 4. All right, now for part C, we're going to get a little more complicated. We're going to have 3 transformations in one. So we're going to take 2/3 times the f of x minus 2 plus 1. So what does that look like for our function? 2/3 times f of x minus 2 plus 1. So f of x is equal to x squared, or sorry, x to the 4th. F of x equals x to the 4th. So f of x is x to the 4th. So I'm going to take 2/3 times f of x, which is x to the 4th. But then I also need to subtract 2 directly to the x. So I'm actually going to do parentheses x minus 2 to the 4th and then plus 1. I want to make sure that that negative 2 is with the x, and then I'm taking that whole thing to the 4th power. And then plus 1. So what transformations occurred here? Well, the plus 1, I'm adding 1 to the entire function. That shifts the function up 1 unit. I'm subtracting 2 only to the x, directly to the x. That shifts the graph to the right 2. And then I have 2/3 times x minus 2 to the 4th. So 2/3. I'm taking 2/3 times this, our entire function here. So, or times f of x. What does 2/3 do? Well, 2/3 is not greater than 1. 2/3 is less than 1 and greater than 0. So I'm going to have a vertical compression by a factor of 2/3. All right, why don't you try one on your own? So this time your parent function is f of x equals x to the 3rd. The transformed function is -1/2 times f of x plus 5 minus 100. So you're going to rewrite the function using those transformations, and then you're going to describe what transformations took place. Press pause and then press play when you're ready to check your work. Okay, so your transformed function should look like -1/2 times x plus 5 to the 3rd minus 100. So then we have 4 transformations that occurred here. The first being this negative reflects us over the x-axis. Adding 5 shifts, just kidding, it shifts us left, not right. 5 units. The -100 shifts us down 100 units. And then the 1/2 is less than 1 but greater than 0. So we have a vertical compression by a factor of 1/2. I hope you got the same answers as me. Okay. So next, we're going to identify the transformations that occur to f of x, and then we're going to graph them. So I'm going to walk you through example 2, and then I'm going to have you work on example 3 on your own. So for example 2, our parent function is f of x equals x squared. So this is our parent function. F of x equals x squared. So when I graph this, I'm just going to pick a few x values, find some y values, and then plot those points. So let's do like -2, -1, 0, 1, and 2, plug them into the function. So then y would be -2 squared, which is 4, -1 squared, which is 1, 0 squared is 0, 1 squared is 1, and then 2 squared is 4. So let's plot those points. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And we see the shape of a parabola taking place, which makes sense because, hey, this is a degree 2 function. So it should be shaped like a parabola. There we go. So this is the parent function of all parabolas, basically. So now we're going to take that parent function and we're going to do some transformations and see how that impacts the graph. So the first transformation we're going to do is we're going to take 2 times f of x. So 2 times f of x. Remember, f of x is x squared. So we're going to take 2 times x squared because x squared is f of x. So 2 times x squared. So let's do the same x values because when you multiply 2 by the whole function, you're not changing the x values, you're only impacting the y values. And I'm going to show you why in just a second. But let's do -2, -1, 0, 1, and 2 and plug them in. So for -2, we're going to have 2 times -2 squared, which is 2 times 4, which is 8. Then we're going to do 2 times -1 squared, which is 2 times 1, which is 2. Then 2 times 0 squared, which is 2 times 0, which is 0. 2 times 1 squared, which is 2 times 1, which is 2. 2 times 2 squared, which is 2 times 4, which is 8. So 2. Well, how do those y values compare to our parent function? So check this out. Isn't 2 times 4, 8? And 2 times 1, 2? 2 times 0, 0. 2 times 1, 2. 2 times 4, 8. We just took all of our y values and multiplied them by 2. So let's look at our graph then. So 0, 0 stays the same. 1, 2, -1, 2, 2, 8, and -2, 8. So as you can see, if you compare these two graphs here, this one got like skinnier. It got stretched vertically. So, which makes sense because 2 times f of x, well, 2 is greater than 1, remember? So that gives us a vertical stretch by a factor of 2. All right. Now let's do f of x minus 2. So we're taking f of x and subtracting 2 from the entire thing. So we're going to get f of x minus 2. Let's plug in -2, or sorry, we should do the equation first. Let's see here. We're going to take f of x, which is x squared, and just subtract 2. Remember, x squared is f of x, and subtract 2. So again, our x values aren't changing. We're impacting our y values because we're taking whatever x squared is and then subtracting 2. So let's do the same x values, -2, -1, 0, 1, and 2. So let's do -2 squared minus 2 would be 4 minus 2, which is 2. We're going to do -1 squared minus 2, which is 1 minus 2, which is -1. 0 squared minus 2 is 0 minus 2, which is -2. And then 1 squared minus 2 is 1 minus 2, which is -1. And then 2 squared minus 2 is 4 minus 2, which is 2. All right. So let's compare these y values to the y values of the parent function. So check it out. What is 4 minus 2? 2. What is 1 minus 2? Negative 1. What is 0 minus 2? Negative 2. What is 1 minus 2? Negative 1. 4 minus 2? 2. So when I shift my function down 2, I'm literally taking all of the y values of the parent function and just subtracting 2, which lines up with what we just did algebraically. So let's graph this. We're going to take negative 2, 2, 1, negative 1, 2, 2, there we go. And it looks just like the parent function, except we just shifted it down 2. So now we need to do f of x plus 2. So for this one, we're taking f of x, which is x squared, but we're adding 2 directly to x. So we're going to take x plus 2 and square it. Now remember, adding 2 directly to x shifts us left 2. So we had been starting with negative 2 as our first values, as our first x value, right? And then going to positive 2. Well, I'm going to shift that left 2 because I know my function's going to shift left 2. So I'm actually going to start with negative 4 because that is 2 to the left of negative 2. So I'm going to start with negative 4. And then we're going to do negative 3, negative 2, negative 1, and 0. And we're going to plug those numbers in to get our y values to plot for this. So we're going to take y equals negative 4 plus 2 squared. So negative 4 plus 2 is negative 2. Negative 2 squared is 4. And check it out. Our y value didn't change from our parent function. The only thing that changed was the x value that gave it to us. Then we're going to do negative 3. So negative 3 plus 2 is negative 1. You get 1. Then we're going to take negative 2 plus 2, which is 0. 0 squared is 0. Then we're going to get negative 1. So negative 1 plus 2 squared is 1 squared, which is 1. And then we're going to plug in 0. So we get 0 plus 2 squared is 2 squared, which is 4. And check it out. Our y values from our parent function didn't change. We still have 4, 1, 0, 1, and 4. What changed was our x values. Our x values had a shift to the left of 2. So let's go ahead and graph it. We're going to have negative 4, 4, negative 3, 1, negative 2, 0, 1, 1, and then 0, 4. And there's our transform function, which looks just like our parent function, just shifted to the left 2, which is what we expected to happen. All right, so I actually want you to try working through example 3 as much as you can on your own. So I'm going to have you do each part by yourself and then check back with me to make through the video to make sure that you're on the right track. So why don't you go ahead and get f of x equals x cubed graph. I recommend that you just stick with the negative 2 to positive 2 integers for your x values. So go ahead and plug those in, find those points, plot them, press pause, and then press play when you're ready to check your work. All right, so your graph of f of x equals x cubed, it should look like this. It is a positive leading term with a odd degree. So your end behavior should be down and then up, which is what we would expect with all we know about polynomials now. And your table should include these points. All right, so now you're going to do your first transformation. You're going to take the negative of f of x. So write your new function. And then when you take the negative of f of x, your x values don't change. So I would still use negative 2 through 2, those integers. All right, go ahead and write your equation, find your new y values, and plot those points. Press pause and then press play when you're ready to check your work. So your new function should just be negative x to the third power. So when you plug in these values, you get positive 8, 1, 0, negative 1, and negative 8. So your graph actually flips its end behavior because it's reflected over the x-axis. So now our end behavior is up and down, which makes sense because our leading coefficient is negative and our degree is still up. All right. Now you're going to take f of x and add 1. So you're adding 1 to the entire function. Write your new equation, and are your x values changing? Are you adding 1 directly to x or to the whole function? Your x values are not changing, so you can still use negative 2, negative 1, 0, 1, and 2. All right, go ahead and find your new points, write your new equation, and press pause, press play when you're ready to check your work. All right, so hopefully the values in your table match mine, and your graph should look like mine too. Your new function should be x cubed plus 1. All right, now you're gonna take f of x minus 2. So this is the one where you're subtracting 2 directly from x. So think about how that impacts your x values, how that impacts your graph. What direction are we shifting when we subtract directly from x? So because you're subtracting 2 directly from x, you're shifting to the right 2. So instead of using negative 2, I would use 0. Instead of using negative 1, I would use 1. Instead of using 1, I would use 3. Instead of using 2, I would use 4. Did I? Oh, I skipped 0. Let's do 0 plus 2 would be 2. So 3 and 4. So I would use the x values 0, 1, 2, 3, and 4, and then still plug them in and see what happens with those y values compared to the parent function and get that thing graphed. So go ahead and finish this on your own. Make sure you write the function, find your points in your table, plot them on the graph, press pause, press play when you're ready to check your work. Our new function is x minus 2 to the third power, or x minus 2 cubed. When I plugged in these x values, I actually got the exact same y values as my parent function. Because when I shift a graph left and right, that doesn't impact my y values. It only impacts my x values because the x-axis goes left and right. So that kind of makes sense, right? Hopefully. All right, so you do have homework on Math Excel today. It's also the last lesson of the week. When you're done with these notes and this Edpuzzle, you need to go do your homework on Math Excel. And don't forget to get your notes submitted for your weekly notes. All right, I'll see you guys back in class.